Hello.
Morning, everyone. Thanks for joining us on this HeatNet webinar. I think we'll get started now. We've a good attendee list there at the moment, and people will probably join as we go along. Just a little bit of housekeeping just before we start. Could everybody, you'll see on your toolbar there for GoToMeeting, could everybody make sure that their microphone is muted? It's just so we don't get any background interference as we go along. You can probably hear a little bit of it there. So if everybody could mute their background microphone, that would be great. Someone's still on there, but we'll, I'm sure they'll mute as we go. Perfect. Thanks very much. So good morning again, everyone, and welcome to the HeatNet webinar. My name is Declan McCormick. I'm a project manager with Codema. We're also the lead partner on the HeatNet project itself. So I'll just give you a little background before we start on the HeatNet project. It's an Interreg Northwest Europe project started in September 2016. It gets funding of 11.5 million from Interreg Northwest Europe. It has 13 partners across 5 countries in the Northwest Europe region. Its main aims, it's got many aims, but one of its main aims is to try and overcome the organizational, political and socio-economic barriers to rolling out district heating in Northwest Europe. So it's not, as some previous projects are, purely technical. It's more looking at those organizational and socio-economic elements to why district heating hasn't been rolled out in that region. There's 6 pilots involved in the project, so these are actual demonstration projects of 4th generation district heating that are going to be rolled out as the project develops, one in each of the region areas. The project is due to end next July 2020, and at the moment we're working on the HeatNet platform. This is going to be a resource for everybody who's interested in district heating and rolling out district heating in their area. So all the findings of the project will be available on that, including the findings from the pilots themselves. So hopefully that should go live next March or April. That's the plan at the moment, and we can keep everybody updated with that. So on to today's webinar itself. So it's going to consist of 2 presentations, and then time permitting, we will try and have a question and answer session at the end. The first presenter up today is Donna Gartland. Donna's been with Codema since 2013 and is our senior energy planner. Donna holds a Master's in Sustainable Energy Planning and Management from Aalborg University in Denmark, and is currently doing a PhD in District Energy Systems with UCC. She's also the CEO of the Irish District Energy Association. Our presentations will basically try and explain what district heating and the 4th generation district heating is, why this solution is needed in order to help decarbonize the energy system in Ireland and beyond, and why public authorities are essential to the development of these systems. Our second presenter will be John OShea. John's been with Codema since 2018 and is our systems energy analyst. John holds a degree from UCC in civil engineering, a postgrad from Carlo IT in sustainable energy, and is a CIBSE certified heat networks consultant. Before taking up his position with us here in Codema, John worked in the district heating sector in the UK. His presentation will focus on how public authorities can roll out district heating systems in their area, from developing roadmaps and assessing suitabilities to planning and economic considerations for these systems. He'll also take a look at the emerging district heating projects in the Dublin region at present. So as I said, after the 2 presentations, we'll have a Q&A session. And in order to keep the webinar flowing and the presentations flowing, we'd ask you to type your questions in as we go. So you'll see there on your toolbar, there's a little chat box down the end. So that's set now to default for everybody. So if you type something in there, all attendees will see it. So if you can type your questions in here as we go along, we'll make a note of them. And then at the end, I'll take a selection of these questions. I'll try and get our presenters here to answer them. If we don't get round to all the questions, people can email them. Our contact details will be available on the slideshow here. People can email them into us, and we can go into more detail and try and get the answers back to you. So apologies in advance if we don't get around to all the questions, but again, you can email them on there, not resources available. So I think we'll start the webinar now. So I'm going to hand you over to our first presenter, Donna Gartland. Thanks.
Thanks, Declan. So I'm going to start off with a simple introduction to district energy, as we have a range of speakers or attendees on the line from public authorities and from the district energy sector. We're going to start off with a kind of simple explanation of exactly what is district heating and cooling. So to put it as simply as we can, it's basically a system of underground pipelines which are insulated, and they carry hot water and cold water to demands that require either heating or cooling for their space heating and cooling use. So these are all your usual buildings. A lot of buildings like hospitals and large commercial buildings would have very high heat demands and long 24-hour heat demands, which can be supplied by district heating sources. And some of the sources that are typically used for district heating and found in many schemes around Europe are large-scale industrial plants and electricity supply production plants. So when you see large industries like waste energy plants and combined heat and power plants, you'll see large chimneys coming from those, and usually you'll see clouds of white smoke coming from the top, which is actually steam. So in most in most industrial processes and in the production of electricity, most of the losses involved are in the form of heat. So usually what happens when we produce electricity is that heat is dissipated to air through chimneys, or else it's dumped into nearby rivers or lakes to cool down power plants. So what district heating systems do is make use of this heat. So instead of throwing it away, we utilize that and therefore increase the efficiency of electricity production plants and other industrial processes by recycling this waste heat. So these plants provide the hot water to the demands, and it's in a series of flow and return pipelines that are buried underground, and a very high insulation to reduce the losses on the heating. So then to move on from, I suppose these are called traditional or third generation district heating systems. So they're very typical of the district heating systems that you'll find across Europe. But what we're promoting in the HeatNet project is a move towards fourth generation district heating systems. So what these are, and the difference is when you have your demands, the existing buildings at the moment have quite high heat demands and require high temperatures. So traditional temperatures would be around 80, 90 degrees supply temperatures. But as these buildings are retrofitted and improve their energy efficiency, they can be supplied at a much lower temperature, so with lower temperature heat sources. So as these building efficiencies improve, we can actually improve the efficiency of the district heating networks and lower the costs of the networks. So we can then supply with multiple different low temperature sources that are available already from existing buildings and industries. And these are just a sample of some of their typical sources, but my colleague John later on will go through all the various sources that we found in the Dublin area as an example. But just to go through some of them, so typical sources of low temperature would be from river water and geothermal sources using heat pumps to bring them up to the kind of temperatures required. Data centers now are becoming much more prevalent, particularly in Ireland. We have a lot of data centers which produce a lot, not only use a lot of energy, but also produce a lot of waste heat at the other end. So when they're cooling the servers, that heat gets dumped at around 25, 30 degrees. So we're trying to utilize this in district heating networks. And importantly, so not only is fourth generation about lowering the temperature of the network and the supply, but also looking at integrating more renewables into the district heating systems. So moving away from traditional gas-fired and fossil fuel-fired combined heat and power plants to more renewable sources of heat, such as combined heat and power plants powered by biofuels and large-scale heat pumps using renewable electricity. So one of the things that the fourth generation systems can do is to actually integrate the electricity and heating sectors. So without going into too much technical detail, what it can do is it can use electricity from the grid at times when there is a lot of renewables, so a lot of wind power, a lot of solar power. We can utilize that to produce heat through large-scale heat pumps and store this in large-scale thermal storage. Large-scale thermal storage are just large storage tanks which are highly insulated. Very, very cheap way of storing energy, much cheaper than batteries or any of those kind of systems, electrical storage systems. Thermal storage is a extremely low cost way of storing energy, and we use that thermal storage also to use CHP plants, so renewable combined heat and power plants, to produce electricity at times when there's not so much solar and not so much wind available, and in that way we can help to increase the amount of renewables on the electricity grid while also increasing the amount of renewables in the heating sector. So in this way it creates an overall smart energy system by integrating the two markets together. And this is obviously done much easier at this kind of scale rather than trying to control hundreds and thousands of individual heating systems. So we're going to move on to why we should be developing district heating and cooling. So if we look at countries across Europe that already have high levels of renewable heating and cooling in their systems, so you'll see there the percentages of existing renewable heating and solutions in different European countries. You can see the ones with the highest level of renewable heating also have the highest level of district heating. So the green part of the bar chart there are all countries that have high levels of district heating and are all leading in this area. On the other hand, on the other side of the graph, unfortunately, most of the countries that we're involved with in the HeatNet project are all in the bottom 5. And this is why I suppose the HeatNet project is concentrating on the Northwest Europe area, in particular for district heating, because we're kind of really behind and haven't really established district heating as a real way to supply renewable heat. So most countries in North Europe are in the bottom, apart from France, who are doing a little better than the rest of us, but still have very low levels of district heating and cooling. So through the HeatNet project, what we've done was we've kind of analysed all of the barriers and challenges that are common across Northwest Europe. So through the pilot projects that we have in the 6 different countries involved, and we can see that there's a lot of overlap in new markets when it comes to district heating and the barriers, the typical barriers that we come across. And what we find is that when we have when we're trying to establish district heating in new areas, customer risk is a big issue for us. So trying to compete with existing heating systems which are low cost, like typical like gas systems, which are at the moment at a low cost comparative to establishing a new heating system like district heating. It has high upfront capital costs, but the infrastructure itself has a long lifetime. So some of the infrastructure that is put in now, those pipelines can be in the ground for more than 50 years. So it has a long lifetime, but unfortunately there are obviously upfront capital costs into implementing this type of infrastructure. And as you can see, as you go along the barriers and challenges, the technology, the actual technology barriers themselves are the least prevalent and have the least impact on the projects that we've been developing in the HeatNet project. So technology really is not a big barrier to district heating. The technology is available, it's already proven, it's well established, but it's all the other non-technical barriers that are the real issues for us to overcome. And in that way, it's useful to have a range of different stakeholders and different people with different skills in any project team developing district heating systems. So while it seems like a very engineering focused project at the beginning, you do need a range of different types of people involved at the start to actually get a project off the ground. And just as an example of why we're looking at the public authorities and public the public sector, as we're looking at those as providing solutions, is because a lot of the barriers and challenges that we find, and the public sector actually can contribute to and creating some solutions to these. And John later on will go into this in more detail. But for example, creating new low carbon heating policy for at a local level helps to improve the and de-risk district heating projects. Also, municipalities have access to low cost loans and investments, and they can share, for example, trenching costs when implementing the infrastructure with other infrastructure that they're putting in the ground anyway, such as drainage systems, etc. So it's looking at how the local authorities can use their powers and use their existing powers to overcome some of these barriers. And moving on to some specific barriers and challenges that we found in Ireland as an example of the kind of barriers that you find in a new emerging market in Northwest Europe. We have no tradition of district heating and cooling. So there is a lack of knowledge around district heating in general, and this is across all sectors. So going from all the way from academia and research, most models and research that's carried out in Ireland doesn't consider district heating as an option for the Irish heating sector. Public bodies have very little knowledge of how district energy systems work. And even our semi-state utility companies don't have any experience or wouldn't know about the district heating infrastructure. And then obviously at the end of the pipeline, the customers are very unaware of the what district heating and cooling is. So this is a big barrier that we face at the moment, but through things like this webinar, etc., we are working to spread the knowledge and fill this gap. We also have no municipal utilities in Ireland. So all of our energy is delivered by national level bodies. So our gas grid is controlled at a national level, and both our DSO and TSO, which is our transmission system operators and distribution system operators, are both national level bodies. So this is a big difference to a lot of other countries in Europe, where you would have municipal utilities and they would own and operate a lot of the local networks. Our municipalities have a low level of autonomy, not just in this regard, but also in other regards. So we don't have like we don't have a mayor, or a lot of our system at a local level. Our local government is a lot different to a lot of other European countries. We have all of our energy policy and regulations are controlled at a national level, which again is a lot different to other European countries and regions, where, for example, the building regulations may be controlled at a regional or a municipal level. So therefore, it's much harder for us to change and much more difficult for us to change regulations, and it's a much longer process. And under the current energy policy, it was never designed with district heating in mind, and this then again creates unintended barriers for district heating. So, for example, some of the incentives for customers to switch from their existing fossil fuel based systems, so switching from their gas boilers and oil boilers to other renewable technologies and other renewable heat technologies such as heat pumps. There's incentives there and there's grants, but there are no actual grants and no incentives at the moment for the customers to switch over to heat exchangers to connect to district heating systems. So obviously this creates another barrier, because they will choose whatever option is cheapest. So again, this is down to the fact that we haven't really considered district heating as a feasible option in Ireland before. We have no long-term planning, so our energy plans tend to change with political parties, which is obviously creates higher risk for any new kind of renewable systems. And at the moment, we've no national level heat plans. So again, this is a lot different to a lot of other European countries where you would have a plan for heating. We do have plans for the transport and electricity sectors, but we have no plan at the moment for the heating sector in Ireland. So as much as these are all barriers and challenges, things are changing and have changed a lot in the last 5 years or 6 years. And we are working here in Codema with a lot of national stakeholders in Ireland to overcome these barriers and challenges. So just to summarise then why public authorities should be involved. So not only is there the environmental benefits that I highlighted earlier about integrating more renewables and lowering CO2, there are also many other benefits such as economic benefits, where you have the ability to provide lower energy costs. So the cost of heat is lower, and also the maintenance bills are lower because in the customer units, the heat exchangers have no moving parts and therefore very little or no maintenance. It's also a sustainable revenue stream for municipalities. So this creates a new revenue stream, and that instead of that money going out of the economy to pay for imported fossil fuels, this is then instead used and kept locally. It creates local jobs. It's a brand new, for say in Ireland, it's a brand new sector, so it creates a brand new job sector. It also is very attractive for developers, as it's a cost-effective way of complying with building regulations. So our building regulations in Ireland require that renewable energy is and requires a level of renewable energy and a very low level of CO2. And by connecting to a district heating scheme, the developer then doesn't have to put in this technology on site, and which lowers the costs for them. So it makes the area more attractive for development, and also helps them to increase their building energy ratings. And then at a customer level, the social benefits. So with this, because we can supply heat from a lot more different sources and a lot lower cost sources, it helps us to produce and supply low cost heat, which then has an effect on fuel poverty. It also improves the energy rating for the householder, and improves the value of the house or the building. It provides an increased level of comfort, so you're being supplied by a steady temperature level 24 hours. And one of the best benefits I found of ever living with district heating is the hot water on demand. So this is especially I suppose relevant for anyone who has to share student accommodation with 5 other people or have teenagers in the house. You know, having that hot water there on demand instead of waiting for your hot water tank to fill up and banging on the bathroom door. These are some of the benefits that district heating can bring to the end customer. So just to summarise then, why the public authority should be involved. This is a local level energy issue, and at the moment it's not being solved and can't be solved effectively with only a top-down approach. Most of the barriers can be mitigated or de-risked by municipalities. And most countries that have already successfully rolled out district heating and cooling did so through municipality involvement. And most recently, just from an Irish perspective, there are now obligations for municipalities to create a supporting policy for district heating and cooling, which is great. So public authority will be involved in the district heating and cooling sector going forward in Ireland. So to go through, I suppose, the step-by-step of what public authorities can do to help improve the district heating sector, I'm going to pass on to my colleague John, who's going to go through the transition roadmaps.
Thanks, Donna. So today I'm going to discuss how public authorities can develop district heating and cooling in their area. And before I start, it's worth noting that a lot of the work kind of outlined here is based on the learnings from the South Dublin Transition Roadmap, and a link to that document will be shared with the attendees following the webinar. So these are the areas we're going to cover. So basically policy and planning, stakeholder engagement, TechnoEconomic, capacity building. So that kind of covers business models for local authority-led district heating, legal and procurement. So the journey essentially to adopting DH. So as Donna outlined earlier, there are many benefits. And that's the reason we kind of get in the car in the first place and go on this journey. And then I'm going to kind of jump off with where to start in terms of location, policy, market development, and then I'll go on to kind of the step-by-step approach, which kind of makes up the bones of the roadmap. So to start with then, one of the first steps is to include sort of certain elements in your planning policy. So I've outlined some examples that are already in use in Ireland here, so including waste heat utilisation clause, where primary operation on-site generates waste heat. So basically you have to do an analysis of the waste heat that's generated and whether that can be utilised elsewhere in a district heating network. The second part is supporting the development of low carbon heat networks in potential areas. So we'll touch a bit more on what makes up a potential area later. And then kind of once you have designated zones, including a requirement to future-proof any developments within that zone for connection to district heating in the future. So then I also have some examples from other regions in Europe. So there's some from London, Scotland, and Amsterdam, I think. This isn't an exhaustive list by any stretch of the imagination. And the document I referred to earlier, the transition roadmap, will touch on a few more. But again, it's similar, having designated district heating zones in places like Denmark. They use a kind of a metric of 120 terajoules per square kilometre, and anything that has that level of heat demand is designated as technically and financially feasible for district heating. Then you have other things like, giving provision of space for pipe runs and energy centres and thermal storage, basically all the infrastructure that's required in a district heating network. And then I guess maybe slightly more extreme example is the elimination of gas-fired central heating, which is something that's beginning to be adopted in Amsterdam. So I guess where to start then, as a kind of a good initial overview of areas that are suitable for district heating, I'd point you in the direction of the Irish Heat Atlas, which was developed by Heat Roadmaps Europe. And that will, give you a good idea or outline areas where district heating could be feasible. And I guess one of the main findings from this study is that 57% of heat demand in Ireland could be covered by district heating. And then kind of diving down into that in a bit more detail, kind of these are the kind of steps in developing a more detailed understanding of where to start within your region. So basically wherever you can find good heat demand, heat sources, and there's and obviously being cognizant as well of the fact of physical barriers like rivers, large motorways, all that sort of thing that could act as a barrier to run of pipes. And then kind of getting into the heat sources, then this is sort of the approach that was taken with the South Dublin transition roadmap. So we basically covered 17 different heat sources in that study using 70 different sources of data. So they kind of are broken down into three main sections of commercial, infrastructural, and environmental. Say for example, you might have some industrial processes that generate heat that is currently either being sent directly to drain or is escaping through a flue, as hot gas, and all these things can be utilized in a district heating network. And then you have certain items like CHP, which is combined heat and power. So basically, if connecting existing CHP may offer an opportunity to increase the overall efficiency of the unit and increase its run hours and generate more electricity on site, which is very beneficial for for sites which have CHP installed. So this is just a map then of the heat sources that we have a process. So as you can kind of see there, there's a few large clusters of data centers. And as you'll notice, the large grey area, that's actually the Dublin Basin, which it represents a large opportunity in terms of deep geothermal. There's also a large number of surface water spots there, so that's where we had data available on flow in rivers, etc. And we have industrial waste heat sites there in green. So that, as I discussed, that's things like flue gas, heat recovery. And then on the next slide. So this is just a summary of our findings from the South Dublin study. So we found that there was 493 megawatts of heat in the South Dublin area that could be utilised, and that's spread over 115 different heat sources. And it's worth noting as well that the surface water on this one is quite a conservative figure, because we took the dry weather flow and assumed that all rivers were fisheries and therefore had a constraint on how much their temperature could be changed before it would have an impact on the fish. So then moving here is we built on the analysis that was done by Codema back in 2015, which is the Spatial Energy Demand Analysis, which basically breaks down the heat demand in the council by small area. And then we've overlaid that with future land use zones, which may represent future demands. And on the right there, you can see in the map, we've colored these in blue. So these are kind of seen as good areas to catalyze a network. They've got the sufficient heat demand. And then we've obviously overlaid the heat sources on top of that. And then the other thing is the physical obstacles. So, you know, in terms of, there'll be many obstacles to installing the network or complicating it at least. So things like waterways, railway, you know, major roads, heritage sites that might need to be avoided, special areas of conservation. So you kind of just have to be cognizant of all these things as well. And also it's probably worth noting as well that things such as roadworks could be used, it could be aligned maybe with the installation of pipes to kind of reduce civils costs. So the kind of outcome of that then is we've basically taken the demand and the sources and kind of drawn a line around areas where we feel would warrant further investigation in terms of a feasibility study. And then we've ranked them on the left-hand side there. And then also in terms of getting started, one of the important things is stakeholder engagement. So this is the kind of simple process that we've outlined in the roadmap. So the first part being so the identification of stakeholders. So a good way to kind of develop your list of stakeholders is to think about the roles that will need to be fulfilled in developing your project. So things like regulation, customers, funding, installation, operation, all these things. You'll have to think about who will fulfill these roles going forward. And then obviously as the process develops, this list will continually be updated as more and more information becomes available. So on the right hand side then the kind of second step in the process is to rank each stakeholder in terms of impact and interest. So basically you have in the A zone there, they're kind of your key stakeholders who will have a large impact on your project and are highly interested. Kind of step 3 then is to kind of understand the drivers of each stakeholder, and in doing so you kind of have a better understanding of what they're looking for from the scheme, and you'll be able to keep your engagement relevant and more focused. And it's also worth noting that some of these drivers may be positive and some of them may be negative as well. And then in terms of the engagement itself, then we can have this slightly simplified engagement strategy. So all your key stakeholders, you'd engage in sort of two-way engagement, so face-to-face meetings, emails, etc. And then your category B will be people who could potentially have a big impact, but maybe less engaged, but where you kind of share progress on the project with those and kind of ask for their comment. And then kind of stage C, it's kind of more of a keep them informed type situation where, as the project goes on, their impact could increase, and also they could act as a collaborator and influencer with other stakeholders. So it's important to be cognizant of that as well. So then next, we're kind of going to talk a bit more about some of the important steps in delivering the actual projects. So firstly, I'll talk about the TechnoEconomic Analysis. So this is essentially a combined kind of energy and financial model. And these generally act as the main evidence base when deciding on whether to take a project forward or not. So generally any investor in the project will have hurdle rates in terms of rates of return that they require, net present value, all these things that need to stack up. The financial side needs to stack up to kind of push the project forward. This stage also kind of allows kind of early optimization. So you can kind of start to mold, say, your kind of specs for the project, by balancing, say, the cost versus how much CO2 you can offset. And then kind of getting more into the technical side of the TechnoEconomic, then things that are considered are so things like and then I guess also you have to be cognizant of the buildings that are going to be connected and the heating system they have. So older buildings, will generally require higher temperature and will have a lower delta T, which will have an effect on the efficiency of the network. So moving on to capacity building then, this slide quickly just kind of runs through the business model options. So there's a whole range of options when it comes to business model, kind of ranging from fully public to fully private. And the kind of model is chosen based on, the kind of project objectives and the attitude to risk, whether you're risk averse or, whether there's finance available or whether finance will need to be leveraged. And the kind of level of control that's required from the project. There's also a number of procurement options available. So for the TALA scheme, we adopted a competitive dialogue process, and that kind of ticked a lot of the major boxes for us in terms of it was kind of suitable for a complex project like this. The kind of technical risks would be assigned to the person who's best placed. So in this case, the energy supply company, and it also allows us to retain control of the system. And just an example of the kind of process here that we took was, so basically from taking it from kind of initial techno-economic kind of appraisal, which was done by ourselves and Codema, and then taking that through pre-qualification, and then getting the feed in from external experts on the legal side to help develop things like the energy supply contracts. And then I guess just again, kind of going back to the transition roadmap. So this is sort of an example of the steps that we developed in terms of delivering district heating networks in South Dublin. So they're kind of split into short-term, medium-term, and long-term. And I've just highlighted some of the ones in green there, which have already been completed. So the heat map, which I showed you earlier, the ranking of the areas, which I also showed, you know, kind of things like the stakeholder engagement, the legal documents that were developed from the external legal experts, and the creation of the South Dublin District Heating Company, SPV. Yeah, so now I'm going to move on to just talking about some of the emerging projects in Dublin. So the first one is that South Dublin project. It's the Tallaght District Heating Scheme, and the waste heat source for that is data centre in Tallaght. Just to give an overview here, the kind of buildings that will be connected will be a mixture of public, residential, and commercial. So as you can see here, the kind of planned phase 1 is kind of the solid blue line. So that's kind of an indicative pipe network route. And then the kind of dotted line is kind of potential future connections. And to kind of go a bit more into the detail of how the system is set up, we have the data center waste heat and the electricity feeding our large-scale heat pump, and then that supplies our thermal store. And then, as kind of redundancy and backup, we'll have a large-scale boiler, which potentially could also raise temperatures during peak periods where necessary. And then on the right-hand side, we have some of the phase 1 connections, so the local authority buildings, the new housing, and the college campus. And then the dotted line shows some possible future connections, so commercial and public buildings. And I guess the element in this, which people mightn't be as familiar with, is the heat pump. So a heat pump essentially is kind of works like your fridge in reverse. So where your fridge takes heat out of your fridge and vents it through the back through a coil, this will take heat out of the data center and will pump it into our district heating network. So some of the benefits then for the Tallaght District Heating Scheme, so it utilizes the waste heat, which currently has no value. So, and it provides cooling to the data center as well as heating to our district heating network. So it has a very high combined efficiency. It's sort of an integration point between the electrical network and a heating network. So that allows balancing of the grid and greater utilization of renewable electricity. It has a high potential for replication due to the growing number of data centers in South Dublin, which kind of was shown previously on the map. It also contributes to the local authority's CO2 and energy efficiency targets, and it also provides low cost, low carbon heat to residents in the Tallaght area. And the second emerging project in Dublin then is the Dublin District Heating Scheme. So this is being developed by Dublin City Council, and the heat source for this is the Dublin Waste Energy Plant. And essentially this system will start with the Poolbeg SDZ and will carry on towards the Docklands area and passes under the River Liffey. There's a pipe that's already been installed under the Liffey through a service tunnel, so that's already in place. And just quickly, some of the benefits for that area: it utilises the waste heat source, that is the waste from energy plant, and again contributes to Dublin City Council's CO2 and energy efficiency targets, provides low cost, low carbon heat to Poolbeg and Docklands area, and decreases Dublin's reliance on imported fossil fuels. Yeah, so that's the end of my presentation now. So we're going to do a Q&A session. I think we have some questions that have come in.
That's great, John. Thanks a million for that. And thanks, Donna. So I think two very interesting presentations. Hopefully that'll give you an overview of district heating, fourth generation district heating in general, and then also some of the steps needed to roll that out in terms of municipalities, public authorities. So just questions have been coming in since the presenters have been talking. So I'm just going to go through these. There's quite a number there, so I'm going to group a couple of questions together that might have a very similar answer, rather than go through each one individually. And as I said again, anybody who wants any elaboration on any of this can always email myself or Donna and John, and obviously you can get more detailed answer on them. So I'm just going to start off with the first question, and thanks very much for some of the attendees who've been answering the questions for us, which is great. Cut down our work here. So our first question is around basically, I think when we were talking about waste heat and around the temperatures needed for that and how to utilize that. So waste heat of 25 degrees, can this be used for space heating? Do you not need 45 degrees or more? So Donna, if you just wanted to take that.
Yeah, so I suppose there's a couple of answers here. So what we found is looking at other examples across Europe is where they've used low temperature sources like this. You either use them so if your temperature is very low, like 25 degrees, you would use individual heat pumps to bring at the building level, to bring them up to a temperature required for that particular building. So obviously this district heating doesn't just supply space heating, it also supplies domestic hot water. And for domestic hot water, you will need a higher temperature than 25 degrees. So individual heat pumps at the building level will bring the temperature up, specifically up to the temperature required for that building. And providing waste heat in at 25 degrees gives the heat pump a much better efficiency overall. But also for space heating and for highly insulated buildings, you don't need very high temperatures to supply a level of comfort. So instead of traditionally what we do is turn on and off heating systems when the buildings heat up and cool down, so you'd have a kind of more stochastic kind of heating supply. Whereas in district heating, you'd set the temperature at a 30-35 degree level and leave that heating on all the time, so you have a steady state temperature in the building at all times. Rather than switching on and off, and that gives an increased level of comfort and maintains the temperature at that lower temperature.
Great, thanks, Donna. The next one is just a clarification question, I think, on one of the charts that was in your slideshow there.
Yeah.
On the RESH percentage, but what a percentage of what?
Yes, so sorry, that percentage is of the total energy required for heating and cooling. So what I showed was the percentage of renewables in each country towards their total heating supply. So in Ireland, for example, I think we're up at about 7 or 8% now of our total, but in other countries it was up at 50, 60% of their total heat supply is supplied through renewables.
Great, thanks. There's a couple of questions came in. I'm just going to group them together. Generally, they're in terms of the economic viability of these systems, the cost associated with them, in terms of the actual bills going to the tenants, and I suppose broadly, if municipalities are rolling these out or public-private partnerships, are they going to get stuck with the bill? Is the taxpayer going to get stuck with the bill if these systems don't prove economically viable?
Yeah, I suppose there's bad examples of the way district heating could be rolled out, and then there's many good examples of the way district heating can be rolled out. So while there are some bad examples, particularly from the 70s and 80s, where district heating was rolled out and not controlled, and I suppose we didn't have the kind of technology or the experience to roll out district heating effectively, but we only have to look at the countries in Europe that have hugely high levels of district heating to understand that it can and does work effectively if managed well. So one of the things that we would advocate for is as the infrastructure to be publicly owned. So the same way you'd have electricity grids and gas grids, that the infrastructure itself will be rolled out, and therefore you don't have a monopoly controlling the network itself and introducing higher costs. So if you look at, you only have to look at the likes of Copenhagen and Stockholm, where over 90% of the buildings are connected to district heating systems, to understand that it can work and work very well. And these are the kind of systems that we're looking to replicate. Not the bad examples. So we'll learn from the bad examples of what went wrong. We learn from I suppose the Scandinavian examples of what went right. So for example, in Sweden, it is a competitive market, so they compete with all other heating solutions on the market, and customers have a choice to connect. And they still have a 90% take up in the likes of Stockholm, and a very high percentage of district heating across the country. So it competes with other heat sources without having to make people connect to anything. And in Ireland, we will have increased carbon taxes now in the future up to 2030 and beyond, as we struggle to meet our targets. So district heating, using multiple different heat sources into the one system, is a much better way of ensuring that customers aren't subject to increasing carbon taxes on fossil fuels, where they're only stuck with, I suppose, one supply, either through gas or oil, etc. Is there anything else to add to that, John? No. Okay.
Brilliant. Thanks, Donna. The next was just from Louise McGarn. Apologies, Louise, if I've mispronounced your name. Just looking for details on the obligations for municipalities for that supporting planning policy on DH. Now, this might be something we could follow up on email without going into too much detail on.
Yeah, I can't name off the exact RPO that's in the plan, but it's in the, if you were to look at the examples for the Dublin region that we know very well, it's in the Eastern Midlands Regional Assembly's new Regional Spatial and Economic Strategy. So that's, to put it in acronyms, the EMRAs or SES. It's in there as there's one or two RPOs specifically on energy planning and zoning, and looking at areas which are suitable for district heating, which the local authorities now have to carry out. But we can follow up and provide details of that in a follow-up email.
Great, thanks, Donna. Again, I'm going to group a number of questions here. These centre around the waste heat from data centres, as we were talking about data centres as a source. Generally, is there enough load coming out of current data centres and future ones in terms of waste heat? What happens in the winter, when obviously conditions are cooler, but that's when you do need your waste heat coming out of them. So I don't know who wants to take that. John, yeah, thank you.
Yeah, so I guess as a kind of a metric, the majority of the electricity consumed by the data center is converted into heat via the servers, and that process is pretty much constant throughout the year, so there is a constant supply of heat. I think it will depend on the type of cooling system in the data center, with new cooling systems that use free cooling and things like that. That may be reduced, but there is also areas within data centers that will always require a certain amount of cooling. So once you kind of have a good analysis done at the start in terms of what the heat output from the data center will be done, and in the case of Tala, that was a requirement in the planning that was done. So we have a pretty good indication of what the availability of the heat will be coming from that source.
Great, John. Thanks for that. So I'm just going through some of the other questions here again. Joseph Grandma Palo, apologies, Joseph, I've got your name completely wrong, I'm sure. Just wants to know, are DH systems just for energy users, or can producers be admitted as well? So can it be prosumers in the system?
Yeah, so just, I suppose, we're at the moment where I just highlighted the buildings as users, but definitely just, yeah, I think it's something that we want to future-proof the systems to be able to do this in the future. So there's prosumers as well as consumers, and it's kind of what's termed, but I think we didn't want to go into 5th generation district heating, but it's kind of what's termed as it's kind of the next generation of district heating now, where all buildings can also produce and supply heat into district heating systems as well as take the heat. So it'll be just the same as I suppose an electricity system would work, where you'd produce as well as consume in the future. So that's what we'd hope for.
Thanks, Donna. Again, I have a group, a couple of questions here from Jackie Cullen. Generally around business case analysis, what's the lifetime or standard contract lengths for that, and should the DH networks be public utilities or private solutions?
Yeah, I guess in terms of the life, is that the lifetime of the asset?
Yeah, well, I think it's generally because the assets is such a long lifetime that in general, what are the contract lengths when you go out? So I suppose we could refer to current ones in Dublin at the moment, maybe? Or? Yeah,
I guess. Yeah, well, current ones in Dublin would be far shorter than the 50 years anyway. They're generally over sort of a fixed period and then renegotiated at the end of that period. You know, and that's done, you know, consecutively throughout the asset's life.
Yeah. And in terms of the public utilities or private solutions, I know the Danish model in terms of the infrastructure for the systems, the advice would be that remains in municipality hands. Is that correct?
Yeah, I think we'd consider, like, any big infrastructure like this, it'd be better if it was publicly owned and controlled, where there's low rates of return required on such infrastructure, such as gas grids and electricity grids. When rolled out, we'd like to see them being rolled out in the same way as other public utilities, and then open to anybody to supply into and take from, rather than privately controlled, and which will increase costs.
Great. So fortunately, we've run out of time there. We still have a number of questions, so we can make note of them, and we can get back to the attendees that have asked them questions. And again, if there's any follow-up questions from anyone, just send them on to the contact details, either directly to John or Donna, or if it's any general questions about the HeatNet project, you can send them on to myself. All the details are there on the slideshow. So I'd just like to thank everybody for attending the webinar, and a really good turnout, which is really encouraging. We hope to have a few more of these. I know there's one planned for next year around the South Dublin pilot, as that continues to develop. So we'll obviously keep everybody's details and keep them up to speed with that. You can check out the current HeatNet webpage. Again, the details are on the start of the slideshow. And as I said, we hope that the platform, the HeatNet platform, with all the findings from the project should go live next March or April. Again, we'll keep you up to speed with that. So I think that's everything now. We'll wrap up, and I hope everybody has a good day. So thanks again for attending, and goodbye.